So, today we are going to discuss the phenomenon of internal reflection. If you recall what we learned about how reflection works, some key terms we talked about were the angle of incidence, the normal, and the angle of reflection. The angle of incidence was the angle between the incoming ray and the normal being the perpendicular line to a mirrored surface. And the angle of reflection is the angle between the reflected ray and the normal, which is always equal to the angle of the incoming ray. So, when an incoming ray hits a reflective surface, it will be reflected at the exact same angle in the opposite direction. So, to understand total internal reflection, we need to take a step further by understanding how refraction works. Refraction is when light changes direction as it travels from one medium into another, depending on the density of that medium. Light will bend toward the normal when traveling from a less dense medium to a denser medium, and it will bend away from the normal when traveling from a denser medium to a less dense medium. The angle of refraction, like the angle of reflection, will be the angle between the refracted ray and the normal. So total internal reflection occurs when the angle of incidence is greater than the critical angle, when light is traveling from a denser medium into a less dense medium. All of the incident light is reflected off the boundary of the medium so that it cannot exit the medium and therefore reflects back into it. The critical angle is when the incident ray produces a refracted angle of 90 degrees to the normal. So we're going to demonstrate internal reflection now with this large bottle of water and a small laser pen light. So in order to see the light traveling through the water, what I'm going to do is I'm going to add a small amount of ordinary table salt to the water. By adjusting the angle with the laser pointer, you should easily be able to see the light being completely reflected back into the water so that no light is exiting the water. So I'm going to add a little bit of salt. And this is just so you can see it happen. Okay? And if my lovely assistant could turn the lights off for me, please. Great. So, there's the laser pointer going through the water. And as you can see, if I get the angle just right, you can see how it comes right to the top of the water, but is not able to exit, and it comes right back down again. So this is something that you can easily do at home, and really drives the point home of how internal reflection works. So if we could turn the lights on again, please. Another cool experiment that you can do with internal reflection is found in another video in the PowerPoint attached to this demonstration. By manipulating the angle that water is being poured into a glass, a coin that has been placed at the bottom of the glass becomes completely invisible. So how can internal reflection be used in positive ways? Well, in recent years, fiber optic devices with small critical angles, such as endoscopes, have taken advantage of this interesting characteristic of light. Endoscopes are used in medical procedures to check for cancerous growths. Also, optical fibers are used in phones, computers, TVs, and instrument panels in cars. So, I hope you enjoyed this demonstration. And remember, if you try this at home, be very careful not to shine the laser light into anyone's eyes, because it can do irreversible damage to their retinas. So thank you for watching, and may the force be with you.